Good afternoon, everybody, and welcome to day 2 of Data Champions Online Financial Services. My name is James Bowater, and I am a production director here at Corinium, and I'm delighted to welcome you today. For those of you who joined us yesterday or have joined past Corinium events, welcome back. We're glad you can join us once more. And for those of you who are joining us for the first time, couldn't make it yesterday, haven't necessarily heard of Corinium before, welcome. Thank you for joining us, and we hope that this is the first of many events that you'll join us for. Before we jump into today's sessions, I'm going to take just a few moments of your time to make a couple of housekeeping pointers. Firstly, each session today has got time allocated for our speakers to answer your questions. So please do take this opportunity to put your questions to the speakers. All you need to do is using the Q&A module, you can type in your questions there, submit them throughout the session. You don't need to wait until the end, submit them as you think of them, and we will do our best to get through as many of those as possible for you. We do also have some live polls today. The options will appear on your screen. All you need to do is select your answer, hit the submit button, and really do take that chance to get involved. Give us your vote, give us your voice. We're very interested in hearing from you. Now, in the unlikely event that you do encounter any technical issues during the session, please firstly refresh your browser and re-log into the system. The majority of the time that will fix any glitches, but if it doesn't work, just drop the team a message in the Q&A module and we will help you. You'll also notice an array of downloadable content in your window, including our global online and in-person events calendars. So please do take the time to download that content, take it away, and you can consume it all at your leisure. Now, I mentioned this yesterday, we're running a bit of a competition. We'd like to encourage you to post a selfie on LinkedIn. We want to see your faces, you can see us, we want to see you. So take out your phone, grab a selfie and post it on LinkedIn using the hashtag Data Champions Online and tag us at Corinium Global Intelligence. One person who does that will win a pair of AirPods. So I would encourage you all to take the opportunity now, grab your phone, take a selfie and post that on LinkedIn. That's all from me for the moment. My housekeeping is done. So it's my pleasure to introduce you to our first session of the day. This first presentation is sponsored by InsterSystems and will be delivered by their partner, Jitendra Lula, who is VP and Innovation Architect at Broadridge. Founded in 1978, InsterSystems is the power behind the most important applications where lives and livelihoods are at stake. Its cloud-first creative data technology and interoperable platforms enable healthy data for solution providers and enterprises in financial services, as well as healthcare, logistics, retail, and many other industries as well. From over 25 worldwide offices, it provides 24/7 support to millions of people in more than 80 countries. Now, G2 is a seasoned technology professional within the financial services industry, with experience implementing innovative solutions using transformational architecture aligned with IT and business strategy. Over the past 2 years, G2 has been involved in the build-out of the architecture for Wealth America's management platform, a strategic initiative at Broadridge, building a cloud-based architecture to deliver a resilient, scalable solution to provide an integrated experience and straight-through processing. The solution integrates 40 disparate Broadridge client and vendor applications. G2 is going to be talking about his work in partnership with InsterSystems to develop and deliver a data fabric solution. So with no further ado, I'll hand straight over to G2.
Thank you, James, and thank you for giving me the opportunity to speak. Just to give you a little bit of background of Broadridge, Broadridge is a firm we are a publicly listed company. We have over 5 decades of services background in the financial services industry. Started off as being of ADP. We've spun out of ADP back in 2007. And since then, we have grown to become one of the largest fintech firms in the country today. So majority of our business, we service different segments. Our largest segment we service is in the financial services, back office settlement and clearance space, we also have others in the communication space. So just a little bit of background about us. We are roughly 14 million in market cap. Our firm, we have serviced over 80 markets. We have services across the globe, and we do post-trade processing in multi-asset class, multi-currency across the globe. We also have essentially our offices in over 16 countries. So that's a little bit of background about what we have in the financial services space. And so the high-level market segments we service in the processing space, we service three major markets: capital markets, asset management, and wealth management. We typically handle the settlement and clearance of the on the back office. And in the communication space, we do handle corporate issuance, issuers. And in the communication space, we handle mailings and distribution for a variety of industries to the consumer markets. So our largest growth area has been into the wealth space, is where our largest growth area is. As James mentioned, over the past 2 years, this is the largest area we've been focused on, one of the areas that Broadridge has been focused on. So our key growth areas that we offer to our clients is via mutualization, digitalization, and data and analytics. So today I'm going to focus primarily on the digitalization aspect of what we bring into the table. Well, all three somehow are interrelated and go together. But data and analytics essentially is the foundation area that will service, that underlies and supports the digitalization that Broadridge has been working towards. Moving on, we essentially are focused, as far as our current focus is on innovation. We are focused, we internally have a project that we term as ABCDs of innovation. This is how Broadridge is helping our clients utilize next generation technology. And our ABCDs are focusing our energies and investments in artificial intelligence. Everything from RPA to machine learning is where we're investing our time and dollars into. The second big area that we are investing is in the space of blockchain. Thirdly, we are designing everything being cloud first. We're starting to look at cloud native technologies and focusing primarily on cloud first being our initiative. And lastly is investing in digital. So today I'm going to primarily focus on the last D aspect of it. That's what that I've been working on in the past few years. Right. So as we go on, I'll spend a few minutes to talk about the future state architecture. But before we get into the future state architecture, I'd like to send out a poll to our viewers to see how many of us, we keep hearing about microservices and an API-driven economy. So the first question I'd like to ask our viewers is, how many of you are currently looking at using APIs to access your data? So James, how do we proceed on this one? Do we give the...
Yeah, we can just give the audience a minute or so there to get their answers in. So all you need to do is just click on your answer there, either less than 25%, between 25 and 50, between 50 and 75, or more than 75. We'll just go back to the question there so you can submit those. So again, the question is, what percentage of your data is accessed via APIs? Less than 25%, between 25 and 50%, between 50% and 75, or more than 75. We'll just give people a quick moment to submit their answers. And there we go. There's the results. I'll hand back over to you, G2.
Okay, so fairly interesting that we have our viewers believe 25 to 50% of our applications are accessed via APIs. So we have been looking at the same, traditionally, just like most of firms that have grown through the last 5-6 decades, a lot of our data resides on the mainframe. And almost all our processing until I'd say 20 years back was heavily dependent on the mainframe. We have since been trying to look at accessing this data via APIs and exposing this data via APIs. So I would like to say we are 25 to 50% in that space, but I certainly would be lying if we would say we'd probably be somewhere in the high 20 to 25% is what we were about 5 to 7 years back. So going forward, just spend a few minutes of the approach that we have taken to our future state architecture. Majority of our data, as I talked about, resides on our mainframe platform. And to extract the assets out of the mainframe platform, we have built services. We've been traditionally chipping away and building services and exposing our data via services to our clients. About 5 years back, we took an approach and said, how are we going to rebuild our architecture and build a future state architecture? So the approach we've taken towards that is we're going to start with building what's our foundational components and frameworks that will enable our areas. That would then go on and we'd start doing some replication of data. We understand we cannot just lift the data off our mainframes, off our legacy applications and bring them across without a certain degree of reputation or replication of data. So that was the idea, was to replicate the data. The third part that we were moving towards was we're going to decouple our applications from the APIs and start offering APIs. And lastly, move on towards where we can start decomposing the platforms and slowly breaking up our monolithic applications into smaller microservices-based architecture. So the approach that we've taken towards that is to build API-based messaging and foundational layers for data, right? In parallel, we are essentially starting to make new applications start utilizing our APIs. And once our foundations are built, that conform to the new architecture, we'll slowly start bringing in applications across to start using the modern data layers. So that's the approach we took about 4 to 5 years back, is the approach we went with. Now, focused on the core part of today's topic is data management. And what we've essentially started doing is to look at data management is how do we take this approach? So we do understand data, we have multiple systems and data enters our system. From the time it enters our system to the final delivery of the consumption of the data, data changes shape. We have replication of data, multiple forms of data being stored in different stages. We use a variety of databases, and as data moves across, it changes not the value, but data gets enriched, and we also encounter a certain amount of data loss. So what we've been starting to look at is how do we ensure that we can maintain the lineage, apply the governance, and avoid duplication of data. So the approach we've been taking towards is we're trying to see is, can we build an approach towards integration of data? How do we store the data? How do we access the data? And how do we govern this data? We all understand there is no one solution that is going to enable us to get to a final solution. So we completely understand having a single form of data is not viable, not even feasible. So the approach we have adapted towards it is our approach of what we term as our data fabric. So essentially the core components of our data fabric is we start by normalizing the data and essentially saying, here is the normalized data. So think about it as the ontology or a topology of the data. What we define is effectively, we're defining a normalized format for the data. The second part I encountered is building common APIs. So defining APIs to allow data ingestion and extraction of data. So that's providing a common set of APIs to allow data to be ingested and extracted from our system. The third layer was to be able to provide a layer to perform analytics. So essentially, once we have data in the system, how do we allow clients to derive value out of the data? history, how do we maintain history, how do we store the data in a historical manner, flexible ingestion and extraction we did talk about, and then essentially giving us an ability to do some aggregation of data across our systems. So the entire solution is what we internally started a project around data fabric. So what we understand is a data fabric, it's one thing I want to clarify is data fabric is not a single data store, but it is a collection of databases. This thing could be a series of, you could consider this as a series of different databases and different solutions that come together to form a solution, right? So as we understand that we in the new world, data has to maintain transactional integrity, and something that our traditional DBMS systems offer, right? And we also have to have high-end scalable solutions such as NoSQL. So our data fabric is essentially a collection of both SQL and NoSQL data stores, right? On which we are going to implement data governance, data management, and lineage to enable us to perform operations on. What we started off by is starting with what's an ontology. So breaking data into different domains, defining ontologies on these domains, and effectively giving a single language, if we were to speak if I were to say, for data. So the ontologies describes a single language for the data. And on top of it, we have provided CRUD operations or APIs that allow us to interact with the data. So that brings me to our second question of the day that we were looking at. And how many different database organizations, DBMS systems do organizations have? What would you say in your organization? Do you have less than 3 database systems, between 3 and 6, or 6 and 9, and greater than 9 database systems that your organizations have? So can we take a few minutes, take a quick poll on how many different database systems that organizations currently use?
Absolutely. As before, guys, just click on the option that you want to choose there on your screen, hit the submit button, and we'll give you a minute or so just to submit those options. That question again, how many different data management software systems are in use at your organization? Less than 3, 3 to 6, 6 to 9, or more than 9? I'll just give you another 5 seconds to get your answers in, and we'll move to the answers now.
All right, so something very similar what I would have expected. A third of our participants said that they have more than 9 DBMS systems, and interesting, it's fairly well spread out. When we looked at our data, we did realize we have the same problem. We have multiple database systems in the shop, and it wasn't just multiple database systems. As data travels through our systems, we did recognize that data changes shape. The data is categorized differently in different systems. So that was our challenge that we were looking at. And when we started building our wealth management use case, we did come across the same scenario where we were ingesting data, we were curating this data, and then making the data available back to our clients. One of the biggest scenarios that we had for our wealth management use case was a case around aggregation. Most of our systems were, or I should say, are currently account-centric systems. And when we started looking at our wealth management use cases, a lot of this data required aggregation based on relationships. So that introduced us a challenge as to how do we solve for it. Prior to bringing it on, we used to have data that was curated, was computed nightly into cubes, and these data cubes were then used for analysis and made available. The challenge that that solution posed was that it was more or less static. It gave us a batch view of the data. And with the velocity and with the volatility in the markets these days, clients are looking for more of real-time updated access and aggregations to be performed in real time. So we did work towards it, and we built our use case and said we need an aggregation layer. And because of the demands of the data, we needed to be able to compute this data in real time. Some of the NFRs we had was about 4.2 million accounts, additional 2 million transactions on a daily basis, 42 million positions, and history for 7 years. And we needed the response time in less than a second. So just a very high-level diagram, we have our engines that were processing the data. We would get our positions and balances, basically the financial data associated with accounts. And then the thought we had was we would store the data in a 3-tiered architecture, cache the data, and perform real-time aggregations in cache and have it presented over to the workstation. So we spent a couple of years working, a couple of months working on the use cases, trying to figure out how do we come up with this solution. And we came up with a 3-tiered architecture. So our 3-tiered data architecture was, as data comes in from our core systems, would get into a raw tier, which essentially just captures the data as it comes in without losing any of the attributes, any of the data content. This data then gets curated and stored into a foundational tier, and that is then optimized and stored in. So if we were to think about it, it's a 3-tiered. We have the raw storage. We have essentially our foundational data or stored in a relational third-normal form, to an optimized storage into cache. And to operate on cache, this is what our approach, the high-level 3-tiered architecture we came about. To support this, we did essentially come up with an approach to say, a logical approach would be producers produce the data that lands into some sort of a persistence layer that then gets moved into an optimized view, where data is stored as data objects and compute logic resides into it, and using an API gateway to service our end consumers. So that was our high-level logical approach that we came about. Once we designed this, we had a solution to look at what solutions are out there in the market that would enable us to solve for this solution. Nothing exciting over here. Our data was very well structured. So we figured the persistence layer made sense to be a relational database would be what a persistence layer would be. The optimized layer, we needed a compute and data. We needed an ability to do some aggregations, perform some valuations to be done. So it made sense to have some sort of a caching layer. And then the API gateways were just building APIs on top of it. We went on and conducted a POC. We built the POCs on AWS, and considering we were building it on AWS, said let's go with AWS native solutions, cloud native technologies. So effectively our POC included taking in data, using Glue to ETL the data into, taking the data, putting it into S3 that served as our tier 1 storage, then using Glue to take in the data, ETL the data into Aurora Postgres to act as our ODS, and Redshift for our history, and then taking that same data and ETLing it over into Elasticache or Redis. So that was our first POC we did, performed pretty well. We did run across some challenges with Elasticache where we had to compromise either consistency or availability. So after we went through this solution, we did realize Elasticache was probably not the right candidate for caching, and we replaced it with GridGain or InfiniSpan or one of those industry standard caches. We figured that's what we would use for our caching layer, optimized layer. So along the way, we came across and we looked at Iris, and Iris was being used within our organization and another division in the organization. We looked at Iris and said, what can Iris do for us? So we effectively repeated our same set of POC that we did, except instead of taking the data from the S3 buckets into Postgres, we moved it into Iris and created our Iris data nodes. What this enabled us to do was elimination of the optimized layer. So instead of holding another layer for cache layer, the Iris cache nodes enabled us to do the caching part of it. So we repeated the same POC with ETLing the data into and repeating this set and did a side-by-side compare between the two options. Based on the different options, we came up with 3 different options. One was to use Postgres for persistence and Elastic Cache or grid gain. Second was Iris for persistence and cache. And third was effectively just looking at Postgres and eliminating the cache. So we laid down our options. Effectively, we said option 1 and 2 both. Option 1 was truly aligned with our 3-tier architecture. It was also aligned with our AWS cloud first technology. It was cloud native. And what we did identified, one of the cons was that there was some duplication of data between tier 2 and tier 3 that would require some sync challenges. And then was essentially the cost associated with maintaining 2 tiers. And lastly was some issues with cross-region replication, particularly for the caching layer. When we looked at Iris, effectively same thing. We could report our queries could be reported. We had to redo our ETL layer, but it did provide us some advantages, which is elimination of the grid gain or the caching layer is what it eliminated. It was still somewhat aligned to our 3-tier data architecture. And lastly, it enabled us to provide us a solution for cross-region failover. And lastly, we did look at Postgres alone. It did work very well. The one challenge that it did present was that the applications would now end up having to build some caching. So after looking at those 3 options, we settled on Iris as our middle tier option. So just as a wrap up, where we are, we did choose the Iris for our aggregation layer. We're currently in dev and QA. We're scheduled to go live towards the mid of next year. We've already ported our jobs across. We are right now working on real-time ingestion. We've done our POCs. Our numbers, our ETL numbers seem to be performing better than Postgres. We still need to do some optimizations across the cases. But overall, from a performance standpoint, Iris does seem to be performing. And lastly, where our steps are is we are right now in the process of doing our performance and regression testing. We haven't done any resiliency failover tests, so that's our next step. And lastly, just something to identify is we are looking at using Iris for in some search use cases, which currently is being supported by Elasticsearch. But what we're finding is that does result in duplication of data. So we're trying to see if we can potentially use the Iris iFind capabilities to replace Elasticsearch. That would enable us to eliminate an additional store as well as provide the same level of performance. And I'd like to leave you last with just a high-level topology of how we have structured it. So currently we are using Iris in the East region is defined as a synchronous replication with the primary and the mirror spread across 2 AZs. That gives us high availability in region 1, and we're doing an async replication into region 2. So if we were to fail over, we are expecting a near 0 RPO for the cross-region failover. And I think that's where I am. How am I doing on time?
Yeah, that's perfect timing. We've got about 15 minutes left for questions, which is generally exactly what we aim for. So perfect timing. Well, I'll go straight to the questions. Firstly, thank you, Jitu. That was really, really great. Some useful insights there for everyone, I'm sure. And just a reminder, guys, if you'd like to ask a question, You can use the Q&A module, just submit those in there, and we'll get through as many of those as we can. So I'm going to jump right into it. The first question that we had through was, what are the two caches that you use to replace the EL?
What are the two caches? So we did the two tests that we did. We did one with InfiniSpan, and there was a second test that we did was using Gemfire. Were the two different caches, caching technologies that we did. So our original POC was done using Elasticache, the Redis Elasticache on AWS. Post that, we did do a brief POC with Apache InfiniSpan.
Great. The next question we've got through here, so the benefit of use for the Iris software over the different AWS services is simplicity, less moving parts, real-time, consistency. What would you say are the kind of the key benefits there for using Iris over the different AWS services?
So the big thing that we save right here is the duplication of data and keeping the data in sync between the tier 2 and tier 3. That was one of our advantages. The other thing that we did look at Iris was we could always revert back considering this built-in SQL. I'm getting an echo. So as far as the build-out, the simplicity of build was certainly one of the factors that came into play. Was instead of us having to build something on a special using an API, we could use straight native SQL. So that was one of the advantages, was the simplicity of build, elimination of the duplication of data being the other reason. And cost was the big factor. So between the three of them, the cost, the deduplication of data, and the simplicity of use.
Absolutely, and that's why you went for the InsterSystems Iris rather than an alternative there. Yeah, absolutely. Thank you very much for that one. We've had another question in here. It says, what are some of the use cases that this solution will be addressing? Do you machine learning modeling in the roadmap as you go live? Do you envisage machine learning modeling in the roadmap as you go live?
So we do have machine learning in our roadmap, but we don't believe we are going to be, at this moment, we haven't considered using Iris to support that use case. Our current use case that we with Iris is very geared towards an aggregation layer aspect of it. We are, as we're expanding into search, we are looking at evaluating the NLP modules for search purposes. But beyond that, we haven't looked at any use cases for machine learning with Iris, and not at this moment in time.
Okay, great. And on to the next one. Here we go. What was the biggest challenge faced by you in the digital transformation journey?
So the biggest challenge that we faced was unwinding the monolithic applications that we have. So I guess that is probably the similar problem that most firms that have all their data sitting in those monolithic applications. The biggest challenge that most of us face is probably the same thing, is how do we unwind it? How do we break it into smaller pieces? And considering a lot of this data and the logic has been sitting in those monolithic applications for years and years, it's very hard to unwind that data and bring it down. So that was probably one of the biggest challenges that we faced, is how do we get that knowledge out of those monolithic systems into more modern technologies?
Yeah, I can imagine, yeah. So the next question, we're firing through them here. It's kind of a rapid fire question and answer session. So what kind of software-based tools do you use for deploying data governance frameworks?
So we have been evaluating, right now we are looking at two different products. We are looking at the Informatica DGO tools from Informatica, and also Collabra is the other tool that we are investigating. We haven't made a final selection, but those are the two different tools that we are currently evaluating.
Great, thank you. Did you ever consider or compare Azure against AWS?
So we did look at Azure, but we have a cloud governance team that came about and did the evaluation of the clouds. We looked at, we have pockets of data in the IBM cloud. We have some in AWS. We also have a tiny little footprint in Azure, and so far not in GCP, but we do have small footprint in Azure as well.
So yeah, so combination.
Those decisions were made outside. I personally was not involved in the decision making between Azure versus AWS, but we did go through the process of evaluation between the different vendors.
Great. And so next one, I don't know what number one. This is the next one. What do you mean by flexible data ingestion, and how did you achieve that in this implementation?
So basically what we're trying to do is we're looking at different formats of getting in data into our systems. And what we have effectively been building is right now we're focused entirely on Glue as our transformation logic. And we're looking at using Mule and Glue in combination to do our ingestion into our system. Our transformation logic is the same that we are reusing, whether the data comes over any medium, whether we get it over a file, over a Kafka streaming topic, or an API. So what we are essentially, from a flexible data ingestion, we are essentially enabling clients to do multiple ways of sending us data, and we are handling the transformation. So we are opening up our systems to enable clients to send us data in their formats, and we will handle the translation on our side using industry tools for transformation.
Great, thank you. And now we have, how did you narrow down the technology selection options to 3 possible options?
So the 3 choices were, we have to essentially, when we came down with our data architecture, we had to figure out different approaches. The choices were fairly simple. We were moving on to the cloud. AWS was our preferred vendor, and the AWS native solution was the proper direction for us to go towards. So that made it the choice very simple. It would be either an RDS or an AWS Aurora would be our persistence layer. So that was a very clear cut, no questions about it. When we came down to the caching part of it to store the optimized storage, we had effectively an AWS native solution with Elastic Cache, or an industry standard caching compute grid or data/compute grid. So that's what was our choice of the selections. There were plenty of vendors in that space. From a second tier, it was very clear it would be a relational database. Data was fairly structured, relational database. AWS native would make a perfect candidate for Aurora or Postgre or RDS. And so when we came onto it, and later when we bought an Iris, the good part was we could port over our tables, our data, with minimal effort and minimal amount of rework to port over from Postgres into Iris. So that is how we came about. Now, could there be more choices? Yes, but given our time and resources, those are the 3 solutions we ended up on.
Great, thank you. We have another one here. Did you also do some kind of master and reference data management? If so, how did you go about that?
So yes, we do have a master data management solution. What I did describe here is effectively just the financial data aspect of it. Supporting to it, we do have an MDM product that we use, and we have an internal homegrown MDM product, and we also use an industry standard MDM products out there. So from a reference data standpoint, we are just replicating a small subset of data into Iris, into our aggregation layer, but we do have an MDM product that handles the reference data, particularly around clients, securities, accounts, are handled by an MDM product. That is as a part of our data fabric solution, but that is not what is stored in Iris. Iris is not used for our MDM, for our reference data.
Great, thank you. Here's another one. You did mention Kafka. How is that currently used in BR? Could you elaborate a little bit on that for us?
So we are using Kafka for streaming. So we are using Kafka for a few purposes. One is as data travels through our system, gets enriched, and for posting purposes, Kafka is used as the medium to ship the data to the aggregation layer. As the aggregation layer updates them and enriches this data, it uses Kafka to publish out notifications when events happen. So we are using Kafka both for ingestion of real-time activity as well as distribution of data, both for change data capture for CDC as well as to notify significant business events. So we have a larger footprint of Kafka, but from an aggregation perspective, two purposes, ingestion and streaming of data.
Great, thank you. Obviously, we've been talking quite a lot about caching of data. So there's a question here around how does the solution scale up when the number of client queries increases?
So we should actually maybe go back one slide. Can I just go back one slide? So if we can see up here, right on the top layer is where the client services are, and they hold the cache layer of it. So as far as the scale out is concerned, our client services is built on a microservices-based architecture using Spring Boot and EKS. So we can scale out this tier to get a scalability. Right now, we are deploying the cache nodes into the container that enables us to scale out the solution. We need to scale out the data. That can be only based on growth. If we have significant growth and data needs to increase, we may end up adding additional data nodes. As far as the cache nodes are concerned, these will scale out, and we have done some performance testing on it to demonstrate that, or to validate that the data nodes can scale out. Take it back. The cache nodes can scale out.
Yeah. So I think we've probably got time for one more. We've got about 2 minutes left, so we're just going to get in one final question. If your question hasn't been answered, I'm sure Jitu would be very happy for you to reach out to him, perhaps on LinkedIn or any of the InsterSystems team. I'm sure they'd be very happy to connect with you as well if we haven't got through your question today. So I'm going to go for the last one now, Jitu, which is, what kind of controls and checks have you built into your system to ensure the data quality?
So as far as data quality is concerned, we are putting in data governance. So we have, starting with the very simplistic ones, we do have threshold validations and threshold checks that are applied onto the data. We also are using a rules engine with rules to ensure that the data that's coming in is validated and it conforms to the different rules that get applied on it. So both as far as batch is concerned, in batch, we do have controls that we have in place that ensure data quality and goes through the data governance to get a golden copy of the data. And similarly, in real time, we have similar rules and checks that we have in place. I'm not sure if I answered the right question.
No, I think so. I think that covered it off. Thank you very much. Unfortunately, as I say, we are out of time for that session now, but But a big thank you, Jitu, for sharing your experience today, and to InsterSystems for sponsoring the session and bringing us all together. So we